Hello everyone, this is the first lesson recording for day 8, 9-5, nth roots of complex numbers in polar form. And this is actually the last of the new material. That means that next class we're going to spend some time doing review. In the following class we're going to have a unit test. So the year is quickly coming to an end. So let's make sure that we finish strong. Alright, so to get us started, what does roots mean when I talk about nth roots of complex numbers? Well, let's start with something that we already know. What is square root of 25? And I hope you're all telling me it is 5. Why? Because 5 times 5 is 25. So square root of 25 is 5. Now some of you might be thinking, why is this not negative 5? Because negative 5 times negative 5 is 25 as well, right? But we don't say that. Why is that? Because the radical implies the principal root only. Okay, so the square root symbol implies, let me just write that down. The radical implies the principal root only. And what do we mean by principal root? That means it has the same sign as the radicand. Has the same sign as the radicand. And what is radicand? It's this number inside the square root symbol. In this case, this 25, positive 25, it has a positive sign, so we are only considering the principal root. Okay, so another example would be, what is square root of 16? And that's just going to be 4, because 4 times 4 is 16. What about cube root of 27? Well, I know that 3 times 3 times 3 is 27. So it's going to be 3. Or if I have cube root of negative 8, that's going to be what number multiplied to itself 3 times is negative 8? That's going to be negative 2. Notice that the radicand and the answer has the same sign. Okay, so that this is what we mean by principal root. In contrast, okay, so in contrast, if I said solutions, find the solutions to x squared is equal to 25. Now this is a whole new ballgame. Okay, so in this case, we're dealing with a variable. One number when it's squared is going to be 25. So in order to solve for this, we would take the square root of both sides. Remember? But when we take the square root of both sides, even root, the final result being odd. So square and square root cancels out, and you have to remember there's a plus or minus sign right there. So then the left-hand side simplifies to x here is equal to plus or minus plus 5 or minus 5. So we actually end up with 2 solutions. There is a difference between this situation and this situation here. Okay, because and the reason being that we're dealing with unknown value, unknown number that could be equal to something squared is equal to 25. Okay, so here x is the roots of 25. X is the roots of 25. Alright, so let's go back to what we learned from last lesson, because that's actually going to help us. So if you recall from last lesson, we learned about de Moivre's theorem. And I'm going to rewrite that. because the new formula that we are going to use is very similar to this. So de Moivre's theorem said that if I am raising some complex number to the power of n, then that it can be if it's in polar form, this can be written as the radius or the modulus to the raised to the power of n multiplied by cosine of n theta, n being the power that we're raising it to, plus I sine of n theta. Okay, so and here you're seeing that raised to the power of n, modulus is raised to the power of n, as well as the angle measure is multiplied by n. Okay, so this was from the last lesson. Well, the formula that you're going to get today looks like this. So if I am taking the root, okay, so for a positive integer n, the complex number number z is equal to r multiplied by cosine of theta plus I sine of theta. So z is a complex number here, okay, has exactly n distinct roots given by this formula right here, r nth root. Okay, so this is the index, and we're taking the nth root of the modulus. So here, if I have z raised to the power of 1 over n, is going to be expressed as r multiplied by cosine of theta. Okay, so before we were raising it to the power of n, now we're dividing. So we are taking the nth root of the radius, but instead of multiplying by theta, we're actually dividing by theta. N, divide by n, but we actually have a little bit more, something a little bit more to it. You end up taking into account coterminal angles of the polar coordinates. Okay, so I sine of, again, theta plus 2 pi k all over n. And this is where k is 0, 1, 2, 3, all the way to n minus 1. Okay, so and this is the formula. And I'll explain a little bit more about this formula and how to use it in a little bit. But for now, just write it down for me. Okay, so when we're taking the nth root of a complex number written in polar form like this, how do we tackle it? Is we need to take the nth root of the modulus or the radius, and whatever the angle was, we're dividing it by n. Instead of multiplying by n, we're doing the reverse. But before we do that, we need to take into account that we have multiple answers. And if you read this part here, for a positive integer n, the complex number z is equal to r cosine of I sine of theta, has exactly n distinct roots given by. So we end up with n number of roots. Okay, so let me explain what that means. Okay, so if I'm taking say square root, okay, so that in this case, if I take square root, in this case n is equal to 2, right? square root is same as the index is going to be 2. That means we're going to end up with 2 distinct roots or answers. That means 2 distinct solutions that satisfies the equation. Okay, or if I am taking cube roots, then n in this case is 3. That means we're going to have 3 answers. And likewise, if I can continue the pattern, if I'm taking 10th root, that means n is equal to 10. Okay, so you're taking 1/10 of, you're raising the complex number to 1/10, or you're taking the 10th root of the complex number, then you're going to end up with 10 answers. So n has, the value of n gives the number of solutions as well, and the number of solution is going to come into play as we add 2 pi k. And the reason we are adding 2 pi times k, where k is 0, 1, 2, 3, 4, all the way to n minus 1, is because cosine has coterminal angles. So we're just adding the full period, which is 2 pi. And the idea of n distinct roots comes from fundamental theorem of algebra, which states that a polynomial with degree n has exactly n zeros in the complex number system. And you're going to see that as we tackle some examples. Okay, so our first example is to find the cube roots of -8. You're essentially solving this equation. X to the power of 3 is equal to -8. So x cubed plus 8 is equal to 0, or I'm certainly taking a cube root of both sides. So you are trying to evaluate what is the cube root of -8. I rewrote the formula just so that I can use it easily. So first thing is, from earlier we said that this is -2, right? And because -2 times -2 times -2 is -8. And this is my principal root. But is that the only solution? Are there other numbers that's also going to give me -8 when I multiply it together? Okay, so well, according to the fundamental theorem of algebra, since we are dealing with a degree of 3, there should be 3 distinct roots in complex number system. This is in the real number system, there is only -2. However, in the complex number system, there are more solutions. There should be 2 more solutions. So we should have 2 more solutions in complex number. Okay, so these are complex solutions. Okay, 2 more complex solutions. And how do I find that? Use the theorem above to find this. Okay, so to find that, we are going to change this number -8 into polar form. So that's my first step. So step 1 is change -8 into polar form. That is r cis theta. Okay, so if I was to graph -8 here, -8 is simply the complex number with imaginary number being 0. So if I was to graph -8 in the complex plane with the real number on the horizontal axis and vertical axis being imaginary, this is -8. Let's just call that -8 here. And the real imaginary portion is 0i, right? So this is where it is. And what is we have to turn it into polar form. So the radius from the origin, the distance from the origin, r is going to be equal to 8. What is the angle measure? This is my angle measure theta here. What is the angle? That's just 180 degrees or pi, right? So negative 8 in